Welcome to all. In the last video lecture, I have given some introduction on the asymmetric synthesis, which is the continuation of the stereochemistry. In the part 1, I have given a definition for the asymmetric synthesis, enantiomeric excess, diastereomeric excess, and what is meant by optical purity, what are the methods available for the asymmetric synthesis, and what is the importance of uh, a scientist to synthesize optically pure compound. In the today's lecture, which is the part 1 of asymmetric synthesis, we will just go for the applications of the asymmetric synthesis. Okay, it has a lot of applications. So I already told $1 billion of lot dollars spent in the research of asymmetric synthesis. So such a important one is asymmetric synthesis, as equal to the using of hydrogen as a fuel in the normal vehicle. So let us see the applications. So there are a lot of applications. We will consider, we will constrain to 4 applications. Now the pharmaceuticals, number 1. Number 2, drug safety, and the flavors, and agrochemicals. So pharmaceuticals and drug safety, that is essential for the surveillance of the human. Without drug, in this world, without drug, that is the medicine, so nobody can easily survey. Nobody can easily survey. So that much important, the drug plays a very important role. So if you take the pharmaceuticals and the drug safety, so the asymmetric synthesis is very important in a drug development. Many new drugs are developed and which shows a very good ability, enhanced ability. As already told, if we take a pair of enantiomer, one enantiomer shows one activity, another enantiomer shows another activity. So this asymmetric synthesis alters the selective production of the desired product. Suppose in the recipe mixer, one isomer gives a positive result. That is, that will give a beneficiary to the human life. The other isomer which is harmful to the life. Here, what is the role of asymmetric synthesis is to selectively prepare the isomer which is beneficial to the human life. Okay. So that type of development is done by the asymmetric synthesis. And improving the drug potentiality, selectivity, and reducing the side effect. So if a drug is given, it cures the disease, but it has some side effect. The side effect can be because of the presence of some other isomer. Some other isomer means if R is the positive, the beneficiary isomer, the S is the harmful isomer. Some amount of harmful isomer is present, so we have to remove that. So by that way, we can reduce the side effect. And Asymmetric synthesis, it is already told, it is highly costly, expensive. So by doing the research, we will make it very economical, very economical. Okay, and we make the method, custom method to prepare a drug by using asymmetric synthesis for a particular person or a particular disease. So that much very keen and particular drug can be prepared. And other thing is we can create, we can got the pattern so that your research can be protected. So in summary, for as far as the pharmaceuticals and the drug safety is concerned, asymmetric synthesis is a powerful tool. Is a powerful tool in the pharmaceutical industries, contributing to the development of safer, more effective, and economical viable drugs. Economical viable drugs. And the third one is the flavors. So you may ask, sir, what you are talking about the flavors? It is very important? Yes, it is very important. See, drugs and drugs is needed for the surveillance of the human life, but the flavor, it is very much needed for the human to live in a comfortable, to live a comfortable life, to live a comfortable life. Okay, so the flavors, it also includes the fragrance. It also includes fragrance. So the flavors, the enantiomeric sensitivity of aroma compounds. So aroma compounds can be prepared enantiomeric, so particular flavor can be easily obtained. And the asymmetric synthesis can lead to the development of the new flavors or natural flavors. Suppose you are getting some essence from a natural source and the need is very high, or the natural source available is very less, that essence cost will be very high. So we must go for the synthetic method so that the cost will be reduced. In that case, asymmetric synthesis is very much useful. And chirality in the fragrance leads to unique, not as in the natural fragrance. The asymmetric synthesis leads to a fragrance of uniqueness and desirable scents, perfumes, and other fragrance products. In the agro industries, the agrochemicals, we can go for the pesticide development. The pesticide can be eradicated. The pest can be eradicated without affecting the crop. Without affecting the crop. Similarly, the herbicide, the fungicide can also be synthesized by using asymmetric synthesis, and using asymmetric synthesis we can go for the plant growth regulations, and finally the insect pheromones. insect pheromones. So pheromones is a sexual hormones. We will see in the last slide. So that will attract a particular insect to a particular place. If you put that suppose a cage is there, and if you put that pheromones, all the insects that will come into the cage, and we will eradicate all the insects. Okay, so let us go into the in detail. Many drugs used in clinical practice contain one or more chiral centers. These chiral drugs are often used therapeutically. Therapeutically means to use as a medicine to cure a disease, either as pure stereoisomer or as a recipe mixer. Okay, so if the recipe mixer, if there is no side effect, you can use it as it, because a recipe mixer is a cheapest one compared to the pure enantiomer. Pure enantiomer. The beneficial effect of a drug can reside in one enantiomer with its paired enantiomer having. Are you follow my point? See, the beneficial effect of a drug can reside in one enantiomer with its paired enantiomer, comparing R and the S having. First one is no activity. That means one isomer is active and another isomer is inactive. In this example, the R plus dichlorprop is the active enantiomer in killing weeds, which is a herbicide. But on the other hand, the S minus isomer is inactive. The second one is one isomer have more activity and the other isomer have very less activity. So we can call it as some activity. For example, Warfarin is more potent as an anticoagulant. Anticoagulant means it just prevent the coagulation of the blood. It is used for the heart patient, treating heart patient. So Warfarin is more potent as an anticoagulant than its R isomer. And the antagonist activity against the active enantiomer. Antagonist activity means one enantiomer act as a beneficiary effect to the human being, the opposite effect, that is, it will do harmful to the human being. For example, this thalidomide is an effective sedative used to treat morning sickness. Suppose the pregnant lady is there, okay, she always go for vomiting, the morning sickness. Okay, if you take as a recipe mixer, the S-thalidomide is effective sedative used to treat the morning sickness, whereas if it is or thalidomide is there, it is end up with the teratogenic. That means the genetic disorder, that is we call it is a birth defect. The birth defect. And a complete separate beneficial or adverse activity from the active enantiomer. Now, already in the previous example, I have told the only the adverse effect. Here, it may be a beneficiary or the adverse. For example, the L isomer of quinine acts as an anti-malarial drug, whereas the quinidine, which is a D isomer, acts as an anti-rhythmic drug. That means that will reduce the heartbeat. That will reduce the heartbeat. That means if the person is suffering from the hypertension, the hypertension can be reduced. Hypertension can be reduced. So the three-dimensional interaction of two enantiomers with a macromolecule such as an enzyme or receptor to form diastereomeric complexes may result in chiral recognition and significant difference in pharmacokinetic process as well as pharmacodynamics. So if you have the enzyme and the substrate, there is a lock and key method, so that only one enantiomer can lock the fit into that particular enzyme. The another enantiomer cannot fit into that a particular enzyme. So that will regulate the pharmacokinetic process. Pharmacokinetic means the pharmacological, how the particular drug acting in our body or in a biological system. Okay, so we have this example, the R epinephrine. Okay, it is correctly fit into the enzyme active site, whereas the S epinephrine does not fit into the active site of the enzyme. So that is the thing that is happening in the biological system. God is great, because the human being or the biological system, the entire world is created by the God. In our body, yeah, thousands and thousands of chemical reactions are going on. They are regulated. They are regulated by the enzymes, like this. So among the two isomer, only one isomer can react with the enzyme. Another isomer could not. Okay. So let us take the Dopa, a drug which is called dihydroxy 3,4-phenylalanine, is a precursor of dopamine that is effective in the treatment of Parkinson's disease. Dopa was used previously under racemic form, but nowadays only L-Dopa is used in therapeutics. So already I have told, the racemic mixer, that is a danger. One isomer is a beneficial one, and another isomer, enantiomer, will be a harmful one. So the previous days they used the racemic mixer of Dopa. Nowadays they are using only L-Dopa for the treatment of Parkinson's disease. Okay, this is a structure of D-Dopa and the L-Dopa. L-Dopa is a therapeutic, and D-Dopa is toxic. The Parkinson's disease is a deadly disease. It comes because of the age. So I have given what are the symptoms of the What are the symptoms of the Parkinson disease? That is, he cannot walk properly. His neck cannot be properly used, and uh, he cannot speak fluently. It's a deadly disease. Okay, L-Dopa is used for that purpose. Okay, and that is arises because of the agranul- agranulocytosis. That means the is a severe and potentially life-threatening condition characterized by a significant decrease in the number of granulocytes, okay, which is the part of the white blood cell, which is responsible for the immune system, immunity. So, if the immunity is decreased because of the age, the Parkinson disease is a deadly disease. Okay, deadly disease, and it can be treated, not cured, treated by the L-Dopa. So, Antillon co-workers are synthesized L-Dopa by using asymmetric azotidination approach. So, the reaction of imine 1 with ethyl diazoacetate in the presence of catalytic amount of R-vapol and triphenyl borate afforded the chiral azotidine 2 in 90% enantiomeric excess. Then the hydrogenation of azotidine 2 results in the amino acids of 3 on hydrolysis of 3 gives L-Dopa with 98% of enantiomeric excess. So, I given the scheme. So, this is the structure of R-vapol. So, in the part 1 itself, we have seen this type of catalyst. It is a chiral catalyst. The chirality arises because of the restricted rotation. The another drug is known as Naproxen is a propionic derivative and exists as R and S enantiomeric form. Okay, here the S Naproxen, which is therapeutic, that is S isomer has a therapeutic property which exhibits analgesic, antipyretic and long-lasting anti-inflammatory action. It is mainly used for arthritis treatment. And on the other hand, the naproxen, which is toxic to the liver. So this rheumatoid arthritis condition where the joint, the fluid is removed, and because of that there is a damage in the joint. There is a lot of pain because of the rheumatoid arthritis, or that to relieve that pain, the S isomer of naproxen is used. But if you use R naproxen, the R enantiomer, which acts as a liver poison, which leads to the liver cirrhosis. Liver is a soft tissue. If something happened to the liver, it will becomes brittle We call it a liver kerasis. It cannot filter the blood to remove the toxic substances. So, Dairy, a Nobel Prize winner in 2001, performed asymmetric hydrogenation process for the commercial production of enantiomeric pure Naproxen in 97% enantiomeric excess. See, 97% is very high. So, this is a scheme starting from the 2,6-methoxy-naphthalene 2L acrylic acid. We get the S isomer. The enzyme used is the S-binaphthalene ruthenium diacetate complex. Okay. So, another drug is the Propranolol is a non-selective beta blocker that is widely used for the therapy of hypertension, arrhythmias, and hyperthyroidism. Yes, propranolol is 100 times more potent than R plus propranolol. Are you follow my point? Okay. So, we have the R in the S isomer. So, this S isomer is more potent than the R isomer. This S isomer is more active than the R isomer. So, this a beta blocker. The first diagram is the beta blocker, and the second diagram is for the hyperthyroidism. So, there are a lot of symptoms for the hyperthyroidism, the fatigue, and the weight loss, the sensitivity to cold, hyperdepression, memory problems, goiter, etc. So, the R-propanol, as I already told, is less active. So, B.Sc and co-workers used lanthanum, the chiral lanthanum bienol complex, catalyst bienol complex catalyst, asymmetric nitroaldol reaction leads towards the synthesis of S-propanol. So, the aldehyde 1 on treatment with nitromethane in the presence of the chiral catalyst bienol complex to afford the chiral alcohol 2, the nitro alcohol 2 on 10% platinum dioxide catalyzed hydrogenation in the presence of acetone afforded the compound 3. So, the reagent is given here. It's a very good example for the asymmetric synthesis. So, another very important thing is application in the flavor industries is the enantiomer of limonene smell differently. One of the enantiomer S limonene smells of lemon. So, this is the structure of S limonene. This has a smells of lemon. On the other hand, its mirror image compound or limonene smells of orange. So, this is a structure and it has a smells of orange. We distinguish between these two enantiomers because our nasal receptors, which are also made up of chiral molecules, that recognize the difference. A 6-membered monocyclic terpene or limonene has been synthesized respectively by new enantiomer selective intramolecular cyclization reaction, neryl ether using an R1,1-binapthyl 2-benzoxy to oxy-auxiliary as a chiral leaving group leaving of tin 4 chloride. Already I explained what is meant by chiral auxiliary. So this is the equation which gives a synthesis of R-limonene in 94% enantiomeric excess. So this catalyst used the same the ligand, the chiral ligand. The chirality arises because of restricted rotation. Similarly, the 4S plus Carvone, which has a distinct caraway odor, okay, as compared to 4R Carvone, which has a characteristic sweet spearmint odor. So there is a Carvone which has the odor of the caraway seeds. In India, we call it as a zira. The isomer that smells like this. On the other case, the R isomer, which smells like the spearmint leaves. So both caravones are used in the food and the flavor industry. So here this Carvone can be prepared by the, one must notice that along with the application, I just highlighted how it is prepared by the method whatever we were discussed in the part 1. The substrate controlled, the auxiliary controlled, the catalyst controlled, and so on. So here it's a substrate controlled asymmetric synthesis of Carvone. Chiral limonene is treated with natricyl chloride. First, to form limonene natricyl chloride, which is dehydrogenated to carboxamide and finally hydrogenated to caravones. So this is a scheme where the Carvone is prepared from the R-limonene. Are you clear? The insects use chiral messages called pheromones as sex attractants. It attracts. For example, it is similar to odorants. In the case of odorants, as the human being they are using. In the case of insect, pheromones chirality can influence a degree of attractiveness in the insects. For example, Olean is a female attracting sex pheromone of the olive fruit fly. On the other hand, the Olean attracts males of the species. So such a wonderful things is done by the asymmetric. These are all occurring in the nature. What we are doing? We are just imitate the nature and using the asymmetric synthesis, we are preparing that compound. Okay. So here the Olean is a natural powder isolated as a racemate from natural sources, but enantiomeric pure R Olean and S Olean can be synthesized by Benjamin et al. Using chiral bronzed acid catalyst, spirooscillation of readily available hydroxyenol ethers. So this methodology used for the preparation of Olean. This catalyst used, the chiral catalyst, to prepare the Olean. The catalyst is a chiral bonded acid catalyst. Thank you very much. I hope this lecture will be very interesting. I'm very much happy about your encouragement in viewing my lecture. I request you to subscribe. Many of the viewers are not subscribing my lectures. Please subscribe my channel. Subscribe my channel. Like my videos. Share my videos. If and all any defect in the videos, just put it in the comment box so that I can modify that, I can rectify in the future lectures. In future lectures, I am going to give, already I told, I am going to give lectures on competitive exams like NEET, JAM, the IIT, etc. I always welcome your encouragement to put the lectures. Thank you. Thank you very much.